Hi friends, in this video I will explain identical objects in the TCP/IP protocol suite for 5 marks. So first of all we need to write this diagram which will be containing the user and then sender and then receiver. So here we are going to writing on the corresponding layers as a identical objects. Sender of a application layer same as the receiver of a application layer. The identical objects it will be the messages based upon application, the message or maybe file or maybe text, audio, video like that. And then the transport layer which will be having the segments or maybe user datagrams of a sender as well as the receiver. So with respect to the network, we will be having the identical objects datagrams and then receiver side also which will be having the identical datagrams. And then data link layer identical objects which will be the frames. So and then receiver also which will be the same the formats. And then under the physical layer which will be having the objects in the bits. So in the middle we have shown onto the router because only the two layers and then other layers also are present, but we are going to indicating onto the only two layers. So next we will see the what and all the major importance of a individual layer. So as we know that under the physical layer, the data formats of a physical layer it is a bits, right? So in this physical layer, which will be focusing on the transmitting the bits from data link layer as a electrical or optical signal over a physical medium such as cables or maybe wires. It converts a bit from data link layer into the signals that can travel through the medium connecting the devices. So from one layer to the another layer there is a changing or maybe encapsulations are present. So transmission media, the physical connection between two devices is made through the transmission medium which can be either cables or maybe air. So within this we can able to utilize the connection oriented or maybe connectionless services. The transmission medium does not directly carry the bits, instead it transmits the signal that present the bits. Logical communication, despite being the lowest layer, the physical layer enables the logical communication between the device by ensuring that signals are accurately transmitted and interpreted. From a logical perspective, the unit of a data at the layer it is a bit. As previously told that the data format of a physical it is a bits. Even though the actual signals sent over a medium are different in nature. Next, signal transformation. The physical layer converts bits into the appropriate form of a signals. The protocol at this layer defines how these bits are transformed into signals to be carried over the medium. So second layer which is going to deals with multiple links are connected by the routers. So data link layer. There are often multiple paths that datagram can take from the host to its destination. Routers are responsible for to determine the most efficient route. Once the next link is chosen by the router, the data link layer manages the process of transferring the datagram across that link. The link can be very wide or including wired LAN, links layer switches, wireless LAN, wide bands and then wireless WAN. So each type of link may be used at different protocols, but the data link layer has the essential role of ensuring that the packets is successfully transmitted across any type of link. The TCP/IP model does not mandate a specific protocol for a data link layer. Instead, it accommodates a wide range of both standard and then proprietary protocols. At the data link layer, the datagram is encapsulated into a packet referred to as frames, or we can say it as the data format of a data link layer it is a frames. So some link layer protocols offer both error detection and then correction, ensuring that the transmitted data is free from errors. So and then another important thing it will be performed under the data link layer is the error detection and then error correction by making of several mechanisms. So next, network layer. The network layer is crucial for establishing communication between the source and destination of a computer. So and then it manages the host-to-host communication across a multiple device in the path. And then the network layer which is going to performing onto the routing. So that means finding a feasible path from a source to the destination. So in this the internet protocol, it is the primary protocol of the network layer is the internet protocol, which defines the structure and then format of a data packets known as datagrams. At this level, IP also determines the addressing system, ensuring each packet is sent from its source to destination. Forwarding of packets from router to router is fundamental part of IP. And then here we will be having the connectionless protocol and then routing protocols are present. IP is a connectionless, meaning that it does not manage the flow control. So whenever the connectionless mechanisms are present, at the time it will not manage the flow control, error control or maybe congestion control. These features are handled by the transport layer if needed via application. Next, routing protocol. While IP is responsible for actual routing, protocol like unicast and multicast creating a forwarding table to assist a router with the routing decisions. And some of the auxiliary protocols which may supporting onto the IP, Internet Control Message Protocol helps IP to report issues encountered during a packet routing, and the Internet Group Management Protocol supports IP with multicast communication. DHCP, Dynamic Host Configuration Protocol, assigns the network layer address to host. ERP, Address Resolution Protocol, which will convert the network layer address into the link layer address for communication with a specific host or router. So next, transport layer. The transport layer plays a crucial role in ensuring end-to-end communication between a host in a network. It handles the transfer of data between the application layer on one device and corresponding application layer on another device, making sure that messages are transmitted reliably and efficiently. Key functions are encapsulation and transmission, end-to-end communications. Protocols in the transport layer are TCP. So some of the advantages are connection oriented, flow control which will manage the flow control, error control, and then congestion control also it has to be monitored. And then user datagram protocol, unlike TCP, UDP does not establish a connection before sending a data. Each user datagram is sent independently without reference to previous or subsequent datagrams. Next, Stream Control Transmission Protocol, it is shortly known as SCTP. Designed for modern application, SCTP is tailored for emerging multimedia application, offering more advanced features suited to high demand data transmission. So next, the last layer, it is a application layer. The application layer in the network facilitates to end-to-end communication between two application layers. It appears as though a direct bridge exists between them, but in reality communication passes through all the layers of the networking model. Some of the key protocol in the application layers are STP, Hypertext Transfer Protocol, used for accessing a World Wide Web. Simple Mail Transfer Protocol, SMTP, the primary protocol for sending and then receiving a mail. And then FTP, File Transfer Protocol, enables the transfer of files between the host. And then Telnet and then SSH, Secure Shell, facilitate remote access to a site. SNMP, Simple Network Management Protocol, allows the administrator to manage the internet resources both globally and locally. DNS, Domain Name System, helps to find the network layer address of a computer of the other protocol. And then IGMP, so Internet Group Management Protocol, collect the information on the group membership for multicast communication. Thank you.